Hello and welcome to my channel. In this series I am upgrading my DIY CNC router, which I built last year. If you're interested in that or other things around the workshop, you should subscribe to my channel. In this week's project I'm making a set probe for my CNC mill. These components have just arrived at my doorstep and are waiting to be put in my machine. But this week I'm making a set probe for the height of the part, so let's get into it. For this project I didn't make any sketches or drawings, so I was just making something up while I was on the lathe. Here I'm turning down the diameter and I want to push my lathe, so I tried to cut 1 mm depth of cut and it handled it beautifully. It did not chatter excessively. The vibration you can see is I think from the pulley. I'm turning this section down because I'm planning on making an M8 thread. So I'm trying to hit just a bit under 8 millimeters. By pure luck, I actually hit 8 millimeters perfectly. If I was trying for that, I probably wouldn't have had achieved that so effortlessly. But I guess But because of that, I had to take another cut of about 3 or 4 hundredths of a millimeter, so it's just a bit undersized. I do this because I get a better result when I have a little bit smaller diameter. When I cut the threads with the thread cutting die, and I use the thread cutting die instead of single point turning because on this lathe it's a very tedious process of changing out the change gears, so it's just easier to cut it with a die. Okay, so here you can see me cutting the thread. This worked out very good. The thread came out great. The threads came out really good, and with this the first part is done. So now I start with the second part, the isolator part. I made it out of acrylic because I didn't have any round stock. I had to cut it out, which didn't work out very good. But at the end I did get it out. So then I turned down the outer diameter, and here I am turning the recess for the centering part of the first part, so it's centered in the middle. So now after this I drilled and tapped the center hole so I can screw the first part into the base, which I'm making now. The tapping wrench I have is a really cheap and crappy one, but it did the job fine. But this maybe will be a project at some point, a tool that will allow me to cut threads better. I am thinking of a tab follower of some sort, or a hand bushing holder which would guide the tab or the die, which I could put in the tailstock so I am thinking of something just like this, that you could put in the tailstock, and then you can put your tools, tabs and dies in the front, so you're always straight. Here I used the lathe to get the tab out faster. And now I try to put in the first part, but I measured it wrong, the diameter of the recess, and it actually was a millimeter too small. So I had to recut that. And here I am filing two flats, so I can on the side of the first part, so I can screw it in better. The outer diameter of this part is 20 millimeters, so I just filed it down by half millimeter per side. So I would have a width of 19 millimeters because that's a common size um, wrench. This actually worked out better than I thought. Didn't even look bad. So after that, I put both parts together, and they fit pretty good. I could screw it in by hand, at least at the start, and then with the wrench, I could tighten it down. So now I want to turn the top and bottom surface of this part parallel to each other. And for that I want to install the collar chuck. So I had to take off the 3-jaw chuck first. On this machine it's a tedious process. You have to loosen 3 nuts on the back, and then you have to take them out, and you don't have enough space to actually take them out, so you have to loosen all and then take the entire chuck a bit forward, so you are able to take the nuts off. The collar chuck I have is one for W20 Schaublin collets, and you put it in the Morse taper of the lathe, and then you have the drawbar which goes in from the back to tighten them into the spindle. I am using the cold chuck here because it gets me a better eccentricity on the parts than with the 3-jaw chuck, and better squareness. And it is better at grabbing on very small shoulders uh, on the parts, because it clamps all around and not just on 3 points. So now I'm turning down the diameter of the acrylic part to match the outer diameter. Um, Here I went to the back and set the 0 on my DRO so I don't crash into the collet. Then I just turned it down. And after I turned down the diameter, I faced the front, and then I turned it around and faced the metal part very lightly, just so it was square again. Um, and now I drilled a hole in the side of the acrylic part just under the thread of the first part, so I could put the cable in, which I then clamp with a set screw that I screw in from the bottom. I can then clamp the cable. And now we're done. This is the end product. I think it turned out great. It will work fine. The purpose of this tool is so I can put it on top of my workpiece and then push a button and the machine drives down, and when it feels that the cutter is making contact with the plate, um, it will then know where the top of the machine is because I can measure the height of this part, and then it knows, okay, I'm 25 millimeters above the part. Thank you for watching, and if you enjoyed this video, I would really appreciate a like and a subscribe. Until next week.